Welcome to my presentation on fighting malicious designs towards visual countermeasures against dark patterns. My name is René Schäfer, and for this research I work together with my colleagues Preuschoff, René Röpke, Sahabi, and Borchers. So first of all, what are dark patterns? Dark patterns are malicious design strategies on websites or in apps that influence the decision-making of the user in favor of a service owner and potentially go against the user's best interest. Let's use this made-up shop as an example. So far, it looks like a normal shop, but once you take a closer look at the buttons, you realize the malicious formulation. Such manipulations are also called confirm shaming, as they force the user to blame themselves when picking the bad choice. But what can we actually do about intentionally placed dark patterns? Well, there are several options. We could raise the user awareness, publicly shame companies that use dark patterns, create laws against them, or introduce technical countermeasures. Our work lies in the last category, where while there is already work on automatically detecting dark patterns using machine learning, for example, there is still one big open question left. What now? What can we do with the information of an algorithm that manipulative elements are currently visible? We conducted a study where 20 participants were given 2 interactive prototypes. Overall, we embedded 13 different dark patterns in these prototypes. The dark patterns are based on the taxonomy by Matur et al. From 2019. To counteract them, we created modified versions of each pattern that matches one of the 3 visual countermeasures that we introduced last year at the mentioned computer. Our goal was to understand the rationales for choosing the specific countermeasure against each of the 13 dark patterns. The first interactive prototype was a shop where participants were tasked to buy a smartphone. For the second prototype, participants should buy a concert ticket instead. We created 4 versions of each prototype. 1 for each countermeasure and 1 for the baseline where nothing was changed. For the countermeasure highlight with explanation, a red box was shown around the manipulative element. Next to the box, there was a red warning symbol that showed a tooltip when hovering over it. This tooltip explains why the design is manipulative. In contrast to highlight with explanation, the countermeasure hide does not add content to the screen, but alters it to remove the manipulation if possible. This includes adjusting text or even the visual appearance. The last countermeasure, switch, initially looks like hide. However, a button next to the manipulation allows the user to switch back to the original content. With this, switch preserves all the information that was originally present. After interacting with the prototypes, participants chose which variant they preferred for each of the 13 dark patterns. We then clustered the dark patterns based on the participants' justifications regarding their choice. Overall, we found 6 clusters of patterns: unnecessary elements, unclear authenticity, dangerous elements, forced action, biased decision, and complex elements. I am now going to explain each of those 6 clusters. First, we have the cluster of unnecessary elements that contains the 2 dark patterns activity message and high demand message. Here, participants mainly suggested removing the element completely as they did not provide any relevant information. Some participants still wanted to preserve the content. Next, we have the cluster of unclear authenticity that consists of the 3 dark patterns limited time message, testimonials, and countdown timer. For this cluster, there was an even split between participants wanting to see the original, preserve the content, and remove the element completely. Overall, participants stated that they were hesitant to suggest hide as the information could be real. The third cluster, dangerous elements, contains the 2 patterns sneak into basket with an extended warranty and hidden costs that were added in the last step of the purchase. For those patterns, participants wanted to be alerted. Some also stated that highlighting the manipulation would be sufficient. Possibly participants preferred being alerted, as people could lose money over such patterns. The fourth cluster only contains forced enrollment as a dark pattern. In contrast to the cluster of dangerous elements, participants preferred highlighting the manipulation over being alerted. This could be because the pattern itself does not directly cause harm to users. Additionally, participants stated that the pattern could not be changed anyways. The fifth cluster, biased decision, consists of the 3 patterns pressured selling, confirm shaming, and visual interference. Here, participants wanted to remove the manipulation but preserve the content, such that they can make an informed and unbiased decision. The last cluster, complex elements, contains the two patterns trick question and hidden subscription. For both patterns, participants wanted the countermeasure to simplify the content to reduce complexity. Overall, this could be a pre-step towards an unbiased decision. With this, participants chose the same countermeasure for this cluster and for the cluster of biased decision, but for a slightly different reason. Simplifying text could potentially already been done using tools such as ChatGPT. Now that we talked about our 6 clusters of dark patterns, let's put them into context with related work. At Chi 23, Gray et al. Presented their preliminary ontology of dark patterns, where they grouped existing patterns into several categories. If we place the 13 dark patterns from our study in the groups by Gray et al., we get 6 times social engineering, 3 times interface interference, 3 times sneaking, and 1 time forced action. If we now place our clusters of dark patterns in the ontology, we get the following. Unnecessary elements, where participants mainly wanted to remove the elements completely, contains only dark patterns from social engineering. The same holds for unclear authenticity, where participants were unsure whether the presented information was real or fake. Forced action stays within the same category in the ontology, while dangerous elements were both sneaking dark patterns. In contrast to the other clusters, biased decision contains dark patterns from 2 categories, namely interface interference and social engineering. The same holds for complex elements, where 1 pattern belongs to interface interference and 1 to sneaking. Notice that only clusters containing interface interference overlap with other categories. For clusters that share a thicker bar, participants mainly chose the same countermeasure but for different reasons. For forced action and dangerous elements, participants preferred highlight with explanation, while they chose hide for biased decision and complex elements. So, how can we continue from here? Next steps include observing more user interactions, as we could only investigate 20 participants in our study. Additionally, we want to implement our countermeasures in the web and investigate how intrusive countermeasures can actually be. Lastly, we are interested in analyzing trust and perceived protection for automatic visual countermeasures. In this presentation, we talked about visual countermeasures that could be used against dark patterns on the user's end. We conducted a study with 2 interactive prototypes where we embedded 13 different dark patterns based on the taxonomy by Matur et al. We then clustered the justifications for choosing specific countermeasures against each of those dark patterns and compared our clusters to the preliminary ontology of Gray et al. We observed that participants sometimes preferred the same countermeasure but for different reasons. Interestingly, most of our clusters stayed within their respective categories by Gray et al. Only dark patterns from interface interference share clusters with other categories. For more information, please refer to our paper.